Welcome to another lesson on integrating vectored valued functions. In this lesson, we'll determine the specific antiderivative of a vectored valued function given an initial condition. Let's take a look at our first example. We want to find the antiderivative of r prime of t that satisfies the initial condition r of 0. So to find the antiderivative, we want to integrate r prime of t. So we'll have the integral of 3t squared times I minus 6 square root t j. And we learned from our first lesson, we now integrate each component individually. So now we'll have the integral of 3t squared dt times I, and then minus the integral of 6. For square root t, we'll write t to the 1/2 dt times j. And now we'll integrate. So we'll have 3 times the integral of t squared would be t to the 3rd divided by 3 plus a constant of integration, which we'll call c sub 1 times I, and then we'll have minus 6 times, if we add 1 to 1/2, that's 3/2, so we'll have t to the 3/2 divided by 3/2, which is the same as multiplying by the reciprocal of 2/3, plus c sub 2 times j. And now we'll simplify. 3 over 3 simplifies to 1. So we have t to the 3rd plus c sub 1 I minus the 6 and 3 simplify, 1 and 2. So we have 4 t to the 3/2 plus c sub 2 times j. Notice how here we have a family of vectored valued functions because of the c sub 1 and c sub 2. But because we're given the initial condition r of 0, we can find the value of c sub 1 and c sub 2 for the specific antiderivative vector valued function. So if r of 0 equals 1i plus 2j, notice how this tells us when t is 0, the x component must be 1 and the y component must be 2. So if t equals 0, looking at the x component, we would have 0 cubed plus c sub 1 must equal 1. So we know c sub 1 must equal 1. But we have to be careful about the y component. Again, when t is 0, this tells us that minus 4 times 0 to the 3/2 plus c sub 2 must equal positive 2. So notice how this is 0, but the result here is negative c sub 2 equals 2, and therefore c sub 2 is equal to negative 2, which means the vectored value function that satisfies this initial condition is r of t equals t to the 3rd plus 1 times I, and then minus 4t to the 3/2 minus 2 times j. Let's take a look at a second example. We want to find the antiderivative of r prime of t given the initial condition r of 0. So again, the first step is to integrate the given vectored valued function. So we'll have the integral of sine 2ti minus cosine tj plus 1 divided by the quantity 1 plus t squared k. And now we'll integrate each component individually. Notice to integrate sine 2t, we have to perform u substitution, where u is equal to 2t and differential u is equal to 2 dt. So if we divide both sides by 2, notice how we'll have an extra factor of 1/2 when writing in terms of u. And the integral of sine u is negative cosine u, so we'll have negative 1/2 cosine 2t plus c sub 1 times I minus the integral of 2 cosine t, which will be minus 2 sine t, plus c sub 2 times j. Then the integral of 1 divided by the quantity 1 plus t squared will be equal to arctangent t. So we'll have plus arctangent t plus c sub 3 times k. Notice here we have a family of vectored valued functions. So now we'll use the initial condition here to find the values of c sub 1, c sub 2, and c sub 3 to find our particular antiderivative. Let's go ahead and do this on the next slide. So now looking at the x component, when t is 0, negative 1/2 cosine 0 plus c sub 1 must equal 3. Looking at the y component, notice that minus 2 sine 0 plus c sub 2 must equal negative 2. Looking at the z component, notice that arctangent 0 plus c sub 3 must equal positive 1. Well, cosine 0 is equal to 1, so here we have negative 1/2 plus c sub 1 equals 3. Adding 1/2 to both sides, that would have c sub 1 equals 3.5 or 7/2. You need to be a little careful here. Sine 0 is 0. Because of this negative sign here, it's going to be negative c sub 2 equals negative 2. So c sub 2 equals positive 2. And then finally over here on the right, arctangent 0 is 0, so we have c sub 3 equals 1. Which means our specific antiderivative vectored valued function is r of t equals negative 1/2 cosine 2t plus 7/2 times I minus 2 sine t plus 2 times j plus arctangent t plus 1 times k. Okay, that's going to do it for these two examples. Next, we'll take a look at definite integration involving vectored valued functions. I hope you found this helpful.